Right now, something is passing through you. Not air, not light, not sound. Something invisible. Something we cannot touch, cannot measure directly, cannot stop. It passes through your skin, through your bones, through every atom in your body. Billions of particles, every single second. And you feel absolutely nothing. We call it dark matter. And here is the terrifying part. We have known it exists for almost 100 years. We have mountains of evidence. We have confirmed it with telescope after telescope, measurement after measurement, galaxy after galaxy. The evidence is overwhelming and undeniable, but we have no idea what it actually is. Not even close. Let that sink in for a moment. The most successful scientific civilization in the history of this planet, the species that split the atom, sequenced the genome, landed on the moon, and photographed a black hole, that species, us. We have spent decades searching for the most abundant form of matter in the universe, and we cannot find it. We cannot touch it. We cannot see it. We only know it is there because of what it does to everything around it. This is the story of dark matter. What it is, what it does, and why the fact that it is passing through you right now is one of the strangest things about your existence. Let's start with how we found it, because the discovery of dark matter did not come from a single dramatic moment. It came from a problem that kept appearing again and again in measurements that had nothing to do with each other, a problem that refused to go away no matter how many times astronomers checked their calculations. It began in the 1930s. A Swiss astronomer named Fritz Zwicky was studying the Coma cluster, a massive collection of galaxies bound together by gravity. He measured how fast the individual galaxies were moving within the cluster. Then he calculated how much mass the cluster would need to hold them together. Gravity holds galaxy clusters together. The more mass, the stronger the gravity. The stronger the gravity, the faster the galaxies can move without flying apart. The calculation was straightforward. The result was not. The galaxies were moving far too fast, catastrophically too fast. The visible matter in the cluster, all the stars, all the gas, all the dust, everything they could see and measure, accounted for only a small fraction of the mass needed to hold the cluster together. The galaxies should have flown apart long ago, but they hadn't. Something was holding them, something massive, something invisible. Zwicky called it dunkle materia. Dark matter. Nobody listened. Not for decades. Science does not always move quickly. Sometimes the most important discoveries sit ignored for years, for decades, because they are too strange, because they require accepting that everything we thought we understood is incomplete. Zwicky's dark matter was exactly that kind of discovery, too strange to accept, too well supported to dismiss. So it sat, waiting, and while it waited, the evidence kept growing. Other astronomers were noticing the same problem in different places, clusters of galaxies moving in ways that made no sense, individual galaxies with rotation patterns that defied calculation. The universe was full of gravitational effects that had no visible cause. But in the 1930s and 1940s, the tools to fully investigate these anomalies simply did not exist. The measurements were rough, the telescopes were limited, the computers needed to process the data had not yet been invented. So the mystery waited, and the universe kept spinning. Wrong. Inexplicably, persistently wrong. Then in the 1970s, an astronomer named Vera Rubin started measuring something called galaxy rotation curves. Here is how that works. When a galaxy spins, the stars near the edge should move slower than the stars near the center. This is basic physics. The same reason the outer planets of our solar system orbit the sun more slowly than the inner ones. Gravity drops off with distance, less gravity at the edge, slower movement. Rubin measured galaxy after galaxy. She expected to see the outer stars slowing down. They did not slow down. The stars at the edges of galaxies were moving just as fast as the stars near the center, sometimes faster. The rotation curves were flat when they should have been falling. The math did not work at all, not even close. There were two possibilities. Either our understanding of gravity was wrong at large scales, or there was massive amounts of invisible matter surrounding every galaxy, matter that we could not see, matter that extended far beyond the visible edges of the galaxy in a giant invisible halo. This dark halo would provide the extra gravity needed to explain why the outer stars were moving so fast. Rubin spent years confirming this, galaxy after galaxy. The pattern was always the same. The rotation curves were always flat. The invisible matter was always there. This time, the scientific community listened, but accepting dark matter meant accepting something deeply uncomfortable. It meant accepting that the universe we could see, the universe of stars and planets and galaxies and everything we had ever studied, was not the whole story. It was not even close to the whole story. It was a thin, visible layer on top of something vast and invisible and completely unknown. That is a difficult thing to accept. Scientists are human. They prefer explanations they can test, particles they can detect, forces they can measure. Dark matter offered none of that. It offered only absence. Only the shape of something unseen, inferred from the way it pushed and pulled on everything around it. Think of it this way. Imagine you are in a completely dark room. You cannot see anything, but you can feel the air moving around you. You can hear sounds bouncing off walls. You can sense that there are objects in the room by the way sound behaves. You build a picture of the room from these indirect clues. You become convinced the room contains furniture, walls, other objects, but you have never seen them. You can only know they are there because of how everything else behaves in their presence. That is exactly how we know dark matter exists. We have never seen it. We have only seen everything else bending around it, moving because of it, shaped by it, held together by it. And the more astronomers looked, the more they found. It was coming from everywhere. Gravitational lensing, the way massive objects bend light as it passes by. When astronomers measured how much light was being bent around galaxy clusters, the answer was always the same. There was far more mass bending that light than could be accounted for by visible matter. Something invisible was there, bending space, warping light, pulling galaxies together, shaping the largest structures in the universe. The cosmic microwave background, the afterglow of the Big Bang. When scientists measured the tiny temperature fluctuations in this ancient light with extraordinary precision, the patterns only made sense if dark matter existed in precise quantities. The universe's oldest light was telling us that dark matter was real, that it had been there from nearly the very beginning. Structure formation, the way galaxies and galaxy clusters and cosmic filaments arranged themselves across the universe. If you run computer simulations of the early universe using only visible matter, you do not get the universe we see. The galaxies form wrong. The clusters form wrong. The cosmic web forms wrong. But add dark matter in the right proportions, and suddenly the simulations match reality almost perfectly. Galaxy by galaxy, cluster by cluster, every independent measurement, every independent method, every independent line of evidence, they all point to the same conclusion. Dark matter is real. It makes up approximately 27% of the total mass and energy content of the universe. Normal matter, everything you can see and touch, every star, every planet, every galaxy, every atom of everything that has ever existed, that accounts for only about 5%. Dark matter outweighs it by more than 5 to 1. 5 to 1. For every kilogram of normal matter in the universe, there are more than 5 kilograms of something we cannot see, cannot touch, and cannot explain. Now, what is it? Here is where the story gets strange, because after almost a century of searching, after billions of dollars spent on the most sensitive detectors ever built, after experiments deep underground and high above the atmosphere and at particle colliders that smash protons together at nearly the speed of light, we have not directly detected a single dark matter particle, not one. The leading candidate for decades has been something called a WIMP, a weakly interacting massive particle. The name tells you the key properties: massive enough to have significant gravitational influence, but interacting only weakly with normal matter. So weakly that billions of them pass through your body every second without touching a single atom. The reason WIMPs were considered so promising is something physicists call the WIMP miracle. If you calculate how many WIMPs would have been produced in the hot, dense conditions of the early universe, and then calculate how many would have survived as the universe cooled, you get a number that matches the observed density of dark matter almost exactly. The math works out with an elegance that feels almost suspicious, like the universe is hinting at something. Physicists built enormous detectors to catch WIMPs, tanks filled with liquid xenon, cooled to just above absolute zero, buried deep underground to shield them from cosmic rays and background radiation. The idea is simple. If a dark matter particle hits a xenon nucleus, it should produce a tiny flash of light and a small electrical signal, sensitive enough to detect, rare enough that you need to eliminate every other possible source of signal. The experiments ran for years, then decades. Larger and larger detectors, more and more sensitive, more and more shielded. The LEX experiment, the Xenon 1T experiment, the Panda X experiment, the LZ experiment, each one pushing the limits of what human technology can detect, and each one found nothing. No WIMPs, no signal, no detection, just silence. This is one of the most profound failures in modern physics. Not because the experiments were badly designed, they were brilliant. Not because the physicists were careless, they were extraordinarily careful. The silence is profound precisely because everything was done right. The detectors worked, the shielding worked, the analysis worked, and the answer that came back was nothing. Think about what that means. The most sensitive particle detectors ever built, buried deep underground to eliminate interference, running for years, watching for the faintest possible signal, and the universe gave them nothing to work with. Not a single confirmed detection. Not one dark matter particle caught in the act of doing anything at all. The silence is not evidence that dark matter does not exist. The gravitational evidence is too strong for that, too consistent across too many independent measurements. Dark matter is real. The silence simply means we do not understand it as well as we thought we did, that our best guess about what it was turned out to be wrong, or at least incomplete, and that is deeply strange. Because the WIMP miracle was so elegant, the math worked so perfectly, it felt like the kind of coincidence the universe puts in front of you when you are on the right track. Turns out the universe does not care how elegant your mathematics is. It does what it does, and it has kept its biggest secret hidden despite everything we have thrown at it. This does not mean dark matter does not exist. The gravitational evidence is overwhelming. It absolutely exists. But it means that if WIMPs are dark matter, they interact with normal matter even more weakly than our best theories predicted. Or it means WIMPs are not dark matter at all, so physicists have started looking elsewhere. Axions, hypothetical particles originally proposed to solve a completely different problem in particle physics. Extraordinarily light, perhaps a billion times lighter than an electron. But if they exist in enormous numbers, they could account for all the dark matter we observe. Experiments searching for axions use powerful magnetic fields and extremely sensitive microwave detectors, looking for the faint signal that would occur if an axion converted into a photon in the magnetic field. So far, nothing confirmed. Primordial black holes that formed in the first fractions of a second after the Big Bang, from the enormous density fluctuations of that initial moment. Not from collapsing stars, just from the extreme conditions of the early universe. If enough of these formed with the right mass range, they could collectively account for dark matter. They would be invisible, they would have mass, they would bend light and affect galaxy rotation just as observed. The detection of gravitational waves by LIGO opened up the possibility that some of the black hole mergers being detected could be primordial black holes. Some of the detected mergers have involved black holes in mass ranges that are difficult to explain by normal stellar evolution. Tantalizing, but not conclusive. Sterile neutrinos, a hypothetical heavier cousin of the known neutrinos. Neutrinos are already ghostly particles, nearly massless, passing through matter with almost no interaction. A heavier version that interacted even less could be dark matter. X-ray telescopes have searched for the faint signal that would result from sterile neutrinos decaying. There have been hints, possible detections at certain X-ray energies that have caused excitement, and then controversy, and then more measurements, and then more disagreement. Nothing settled. And then there is the most radical possibility. What if there is no dark matter at all? What if gravity itself behaves differently on large scales than our equations predict? Modified Newtonian dynamics, or MOND, proposes that below a certain acceleration threshold, gravity becomes stronger than Newton's law suggests. In the outer regions of galaxies where gravitational accelerations are extremely small, this modification could explain the flat rotation curves without any invisible matter. MOND works surprisingly well for individual galaxies, but it struggles with galaxy clusters. It cannot explain the bullet cluster, a famous collision of two galaxy clusters where the gravitational center of mass clearly separated from the visible matter, exactly as dark matter would predict. And it cannot explain the large-scale structure of the universe or the patterns in the cosmic microwave background with the same precision as dark matter models. Most physicists remain convinced dark matter is real, but the fact that we cannot find it, despite decades of searching with the most sensitive instruments ever built, is deeply unsettling. It suggests that whatever dark matter is, it is more elusive, more strange, more fundamentally different from normal matter than our best theories predicted. And here is what makes this personal, not just intellectually interesting, not just scientifically important, genuinely, physically personal. You are not just living in a universe that contains dark matter. You are not just surrounded by it, you are moving through it right now. At this exact moment, as you listen to these words, dark matter is flowing through your body like water through a net, like wind through an open door, like light through glass. Your body offers no resistance. Your atoms, dense and solid as they feel to you, are almost entirely empty space from the perspective of a dark matter particle. The nucleus of an atom is so small relative to the atom itself that if you scaled an atom up to the size of a football stadium, the nucleus would be the size of a marble at the center. Everything else is empty, and dark matter does not even notice that marble. It passes through the empty space as if nothing were there at all. Billions of dark matter particles, every second, through every cell, through every molecule of DNA, through your brain as it processes these words, through your heart as it beats, through the chair or bed or floor beneath you, through the building around you, through the earth itself, all the way to the other side and out again. Constant, ceaseless, completely silent. As you listen to this, dark matter is passing through you, through the room you are in, through the earth beneath you, through the sun, through every planet in the solar system. The dark matter halo of the Milky Way extends hundreds of thousands of light years in every direction, and we are sitting inside it, moving through it, bathed in it constantly. The density of dark matter at our location in the galaxy is estimated at roughly half a proton mass per cubic centimeter. That sounds vanishingly small, but it means that in the space of your body at any given moment, there are hundreds of millions of dark matter particles passing through you, ghosting through your atoms, feeling nothing, leaving no trace, interacting with the matter that makes you up so weakly that in the entire history of humanity, not a single dark matter particle has ever been confirmed to have interacted with a single atom of human tissue. You are made of the rare stuff, the 5%, the ordinary matter that clumps together into stars and planets and people, and you are swimming through an invisible ocean of something else entirely, something that shaped the universe you live in, something that built the scaffolding that galaxies formed inside, something that is more abundant than everything you have ever seen or touched or known combined, and we do not know what it is. We do not know if we will ever directly detect it. We do not know if it is a particle at all. We do not know if our entire framework for understanding it is correct. The best minds working on this problem have been working on it for decades, and the most honest answer any of them can give is that we are still genuinely in the dark. There is something humbling about that, and something thrilling. The universe is not finished surprising us. The most abundant form of matter in existence is still a mystery, still unnamed in any real sense, still undetected, still passing through us right now in numbers beyond counting. We are the 5%, trying to understand the 95, and perhaps the most unsettling part is this. Dark matter shaped everything. It was there before the first stars formed, before the first galaxies assembled. In the early universe, dark matter collapsed under its own gravity first. It formed the halos, the invisible scaffolding, the gravitational framework that normal matter then fell into. Without dark matter, there would be no galaxies. Without galaxies, there would be no stars. Without stars, there would be no planets. Without planets, there would be no us. You exist because of dark matter. Your existence, this moment, this thought, this breath, is the downstream consequence of an invisible substance we cannot identify passing through you right now without leaving a trace. You are a product of the thing you cannot see. You are made possible by the mystery, and that mystery is still out there, still passing through you, still waiting to be understood, still keeping it secret after 100 years of searching, after the most sensitive experiments ever built, after the brightest minds of multiple generations devoted their careers to finding it. It is patient, it is vast, it is everywhere, and we are only just beginning to ask the right questions, and we have only just begun.